Okay, so I'm going to go over section 1.3. So this is a very quick review of trig functions. So I would normally, this is something that I would, in a trig course, which I think at our school is Math 104. This would take me several weeks to go over. So I'm going to see what I can do just in the next 20 minutes or so. And again, a lot of these notes are from my colleague, Professor Karen Cliff. Okay, so this should all actually be review. So you all should have had a course on trigonometry, and this is just review. And so first of all, we know a radian is just a measure from, and we start from the positive x-axis and we wrap around, let's say, like an angle theta, and so that's our radian measure. And so yeah, so there you see basically 1 radian. So 1 radian is less than pi over 2. So let's see here. So yeah, so let's see here. So and then if on the unit circle, so we know the equation for the unit circle is x squared plus y squared equals 1. So maybe this is an easier way for you to remember cosine and sine. That cosine is really just the x coordinate on the unit circle, and sine is actually the y coordinate on the unit circle. And of course, that's where we get that famous identity, cosine squared plus sine squared equals 1. Okay, so just some common conversion. So we know that 2 pi radians, you go around the entire unit circle, 2 pi radians is 360 degrees. So if you start at 1 comma 0, so if you start at 1 comma 0, like right here, and you wrap around 2 pi radians, you'll be back at the starting point. Okay, so pi over 2, so well, pi radians is 180 degrees. Pi over 2 radians is 90 degrees. Pi over 3 radians, because pi radians is 180 degrees, so you divide by 3, you get 60 degrees. So now, so these are some of the more important angles that we see in trigonometry, like 0, pi over 6, pi over 3, and pi over 2. Now I'm going to talk about that in a minute. Then I don't actually think we talk about reference angles too much in this section, but one thing you probably learned in your trig course, just a reference angle, you take just the ray that's coming out of the origin, and it's the smallest angle between that ray and the x-axis. So so here's something here, and I have this chart right here. Okay, so and so a lot of times students have a hard time. Of course, you know this is going to be open book test, and you'll have your calculator with you because, but so let's say so there are the angles in the first quadrant. So the most important angles that you normally see in a trig course are 0, pi over 6, pi over 4, pi over 3, and then pi over 2. And notice that those angles are going in ascending order, right? The larger the denominator, I mean, the smaller the denominator, the larger the number. So pi over 6 is, yeah, so the larger the denominator, the smaller the number. Okay, so pi over 6 is less than pi over 4, is less than pi over 3, which is less than pi over 2. Okay, and so also you have to remember that, so cosine is the first coordinate on the unit circle, and sine is the second coordinate on the unit circle. So at angle 0, right, at angle 0, the coordinates are just 1, you know, this is, right, 1 comma 0. So cosine of 0 is 1, and sine of 0 is, sine of 0 radians is 0. And as you go towards pi over 2, the cosine is decreasing and the sine is increasing. Yeah, so as we wrap around here, right, the first coordinate is getting smaller, and the second coordinate, which is the height, is getting bigger. And so the famous values are the most well-known, the most widely seen values that we see for cosine and sine. So it's 0 and 1, square root of 3, square root over 2, square root of 2 over 2, and 1/2. And once again, so we see it as we go from 0 to pi over 2, the cosine goes from 1 to square root of 3 over 2. So it keeps getting a little bit smaller. Square root over 2 over 2 at pi over 4 radians. Pi over 3, when we're getting really pretty close to pi over 2, the first coordinate at pi over 3 radians is 1/2. And then at pi over 2, the first coordinate is 0. Right, so that's 0, comma 1. So that, and then it's just the opposite for sine. So you notice how, like in this chart here, it's so for cosine we're going down from 1 to 0, and now we're just going back in reverse order for sine. So this is how one way you can remember if you're just trying to memorize the angles in the first quadrant. Right, so you just so they're the most well-known angles, or well-known, the most widely used angles, and we write them out in ascending order. And the most widely used values we've seen are 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. And they go in descending order for the cosine and ascending order for the sine. And I know you're going to have your calculator, students, but I would actually, I think it just makes life easier for you if you know these. You won't constantly be looking them up. And here is this chart here for what it's. I think you usually see a chart like this in the like in the back of a calculus book where they have all the. Oh, see, this one's actually nice. I have this great chart here with this great circle right here. Yeah, you can see here how the first. If you look here, that quadrant labeled A, the first quadrant, right? Oh, sorry, students. This first quadrant right here, the one that goes from 0 to pi over 2 or 0 to 90. And if you just look at the first coordinates, that's the cosine. Yeah, you see how it's descending. It's going 1 as we rotate in a counterclockwise direction to pi over 2. Yeah, it's going 1 square root of 3 over 2, square root of 2 over 2, 1/2, 0. But the cosine is descending, and the sine is ascending. And that's only in the first quadrant, though. But yeah, so if you're having a hard time memorizing the values of sine and cosine, just start with the first quadrant. And then we have this famous acronym, SOHCAHTOA, which I never really used in my when I taught trig. Maybe that's why my students didn't like me. No, I think I'm just joking. I think they were okay with me. I think it was trigonometry maybe they didn't like. Okay, so first of all, what does the SOH stand for? The S is the sine, and that's equal to opposite over hypotenuse. The SOHCAH, CAH, cosine equals adjacent over hypotenuse. TOA, tangent equals opposite over adjacent. And so when you have a right triangle, that's how we can calculate the cosine of an angle or the sine of an angle, like the sine of pi over 6 is opposite over hypotenuse. So the opposite is 1, right? So the opposite of 1 is 1, and the hypotenuse is 2, right? So here, the opposite is 1, and the hypotenuse is 2, so it's a little hard for me to write. It's a lot of times how you actually define sine, opposite over adjacent, but also sine and cosine are the first and second coordinate on the unit circle. Okay, and then for, now you look at that second triangle, the one where it's an isosceles triangle, it's, where the two angles are pi over 4 or 45 degrees. So we know that the sides opposite the pi over 4 have the same length. So if the sides opposite the angle pi over 4 is 1, then the hypotenuse has to be square root of 2 over 2. And so in the tangent, what is opposite over adjacent? So tangent of pi over 4, the opposite is 1, and the angle adjacent to pi over 4 is 1. So the tangent of pi over 4 is 1. Yeah, in this case, sine, which is opposite over hypotenuse, yeah, it's 1 over the square root of 2. The opposite is 1, and the hypotenuse is square root of 2. And then you can just rationalize the denominator. You get square root of 2 over 2. So students, yeah, I know this is okay. So I've talked for maybe 10 minutes, and this is something that would be a couple weeks in a trig course. So okay, so then we have the reciprocal function. So the 1 over sine is cosecant, 1 over cosine is secant, and cotangent is the reciprocal of the tangent function. So cotangent is would be cosine over sine. Tangent is sine over cosine. So this is just cosine over sine. And then something else very important right here, that even that, first of all, these formulas, we want to know the formulas for the cofunctions, the cosecant and the cotangent. And we'll definitely be using these later on. We're going to talk about what's called integrating functions. And then we have these identities for sine and cosine. So sine is an odd function, right? So sine of minus theta is minus sine theta, right? Because an odd function has this property that f of minus x is minus f of x. And cosine is an even function, that cosine of minus theta is cosine of theta. So remember, the graph of an even function is symmetric about the y-axis. And so the graph of an odd function, you rotate it 180 degrees and you get the exact same graph. Okay, so then here's if you see I have that labeled important, the famous Pythagorean identities. So sine squared plus cosine squared equals 1, or sometimes you see this cosine squared plus sine squared equals 1. It doesn't really matter. Remember, that just comes from up here, right? So we know that the unit circle is defined as, a circle with radius 1. We know that it's defined as by the formula x squared plus y squared equals 1. Well, so I'm just saying x is just the same as cosine of theta, and the second coordinate is the same as sine of theta. So you just plug wherever you see x, you replace it with cosine. Wherever you see y, you replace it with sine, and then you get this famous, probably the most famous identity in trigonometry: sine squared plus cosine squared equals 1. Now let's say we divide each side by sine squared. So you'll get 1, and then cosine over sine is cotangent. So what you'd get is 1 plus cotangent squared theta, and 1 over sine is cosecant. So so if you divide both sides of that formula in A by sine squared, you end up with this other Pythagorean identity: 1 plus cotangent squared theta is cosecant squared theta. And same for, now you divide both sides by cosine squared. So sine over cosine is defined as tangent. So this, once again, divide formula A by cosine squared theta, and you'll get tangent squared theta plus 1, and 1 over cosine is secant squared. So students, at some point, you will be using all three of these identities. And again, we're doing this at some point in the course. We're doing something called integration, and you have to, we're going to need all these identities. You can't do a lot of these problems without these identities. Okay, so then there's the double angle formula. Sine 2 theta is equal to 2 sine theta cosine theta. Again, that's going to be useful later on. And cosine of 2 theta, we can expand that as cosine squared theta minus sine squared theta. But just remember, so if you look at that formula A, right? So in this formula A here, solve for cosine squared. Cosine squared is 1 minus sine squared. Yeah, so you just replace cosine squared with 1 minus sine squared theta. And so another way of writing cosine 2 theta is 1 minus 2 sine squared theta. Or we can replace sine squared theta with 1 minus cosine squared theta. Yeah, and then you end up with there's 3 different ways of representing cosine 2 theta, and they'll all be very useful to us. I'm not sure what point in the course probably over the half point course, halfway through. So again, this is a really quick, so you've seen this before. So this is a really quick just reminder. So students, if you don't remember this, there are references online. It's actually in the textbook, so probably not a lot, but there are definitely lots of trig references online. If you're having a hard time with that, just let me know. So that PER means period. meaning, so let's say we graph sine. That means that the graph repeats every 2 pi units. And that A and P means amplitude. That means the greatest height is 1. Because, again, it's all, see if I draw, not that they're the greatest circles, but you see, there's the unit circle. And what I did is I just wrote out the second coordinates of the unit circle. So at angle 0, the second coordinate is 0. So that's why we start here. So because when you're graphing sine, you're just graphing the second coordinate as you go around the unit circle, right? So if we start here and as we go around, let's just graph the second coordinate, and that's the graph of sine, right? So here, when 0, right? So we're at 0, and see there at pi over 2, right? What do we get there? That's where you get the 1, right? You go back down to pi units. See, that's why you go back down there to 0. Yeah, 3 pi over 2 radians, we're down here, and that's why we have the -1. And then you keep going around the circle. So all the second coordinates repeat. So that's why you get this period, what's called this period of 2 pi. For cosine, again, we're just graphing the first coordinate as we go around the unit circle. So here I wrote out the first coordinates. And so at angle 0, the first coordinate is 1. And then it's pi over, then we have 0, -1, and then 0. Right, so for cosine, at 0, the first coordinate is 1, right? So that's where that 1 comes from. It's just the first coordinate at angle 0. So at angle pi over 2, the first coordinate is 0. So that's why we're down to here. At angle pi, yeah, the first coordinate is -1. That's why we're here. 3 pi over 2, the first coordinate is 0. And then you get back to 2 pi, and the first coordinate is 1. And it just keeps repeating. And then, so here's, I'm just going to say this really quickly, like right here. So if you actually replace x with like bx, you just divide, what's the period? Well, you divide the period by b. And the amplitude, you just multiply, instead of the amplitude being 1, the amplitude is the absolute value of a, because this a could be negative. And I'm sure you did a lot of graphing like this when you took a trig course. So we're just doing everything. Okay, so we're now in week 7 of my Math 104 course. Okay, so the tangent function, remember, that's defined as opposite over adjacent, or sine over cosine. And remember, cosine becomes 0 at pi over minus. So cosine is 0 at minus pi over 2, right? So right, isn't it? So cosine, you go pi over 2. So you start at 0, 0, and you go negative pi over 2. The first coordinate is 0. So cosine of minus pi over 2 is 0. Cosine of pi over 2 is 0. So when you're graphing tangent, as you get close to pi over 2 or negative minus pi over 2, you're going towards infinity. Okay, so well, the sine function, so sine and cosine are positive from in the interval 0 to pi over 2, right? Sine and cosine are both positive in the first coordinate, in the first quadrant. But in this quadrant here, what's called the fourth quadrant, from minus pi over 2 to 0, the sine function is negative, but cosine is positive. So the tangent function is negative. So if you actually graph tangent, as we're getting close to pi over 2, it just goes as high as we want, but never touches the line y equals pi over 2. And as we approach a minus pi over 2, the graph goes down, 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 down as far as we want. And but it never touches y equals minus pi over 2. So those lines that it never touches, they're called asymptotes. And again, you probably talked a lot about that in your last algebra course, asymptotes, where the graph approaches a certain line, either vertical or horizontal, but never touches it. Okay, so the period or the amplitude of tangent, well, remember the amplitude is the highest point of a graph, like the amplitude of cosine is 1, because that's the highest point on the graph is 1. Well, tangent just goes up and up and up, so the amplitude is infinite. And again, and then the period of tangent is actually pi. So the period of tangent of bx is pi over b. I'm not sure it's something we really use a lot, but I'll remind you of that when we need it. And so students, since we're not it's not it's not really a closed book test. So I don't know how, I doubt I'd give problems like this on a quiz. So this is definitely something, if I was in a classroom, I would be proctoring this, but just knowing these different values of sine and cosine, um, um, we could do one of these here. So let's see here. So let's see here. So maybe let's try sine of 4 pi over 3. And so that's, remember sine is the second coordinate. Okay, so now, okay, sometimes this PDF annotator just has a little bit of a hard time here. So sorry, students. So here's your pi over 3. So pi over 3, that's the biggest angle. That's the one that's closest to, so good. So pi over 6, pi over 2, pi over 3 is the one that's closest to pi over 2. Okay, and so remember the sine function is increasing. So, okay, so sine of pi over 3, remember, so we know that sine of pi over 2 is 1. Remember those 5 famous values? Oh, my cat wants to know some trigonometry, sorry. So remember the sine of, okay, so I'm just going to close the door. Sorry, students, I was almost done here. And okay, so sorry, I'll be right back, everybody. Okay, she doesn't want to leave. Okay, so sorry for that. Sorry for that interruption. Okay, so the cat's going to stay. Okay, so she wants to learn some trigonometry. Okay, so remember that chart I drew way back up here? Right, so sine of pi over 3 is square root of 3 over 2 because the numbers go in ascending orders. We go from 0 to pi over 2. Pi over 3 is the one that's closest to pi over 2. So where am I? Down here. So sine of pi over 3 is square root of 3 over 2. So here's your, okay, so we go up square root of 3 over 2. So for 4, so this is 4 pi over 3. And we're going down the same amount. Okay, so the second coordinate here has to be minus square root of 3. I know my writing is terrible here. The second coordinate has to be minus, because we're, instead of going up square root of 3 over 2, we're going down square root of 3 over 2. So the sine of 4 pi over 3 is minus square root of 3 over 2. And the cosine would actually be, again, we're going, instead of, we're starting at the origin and we're going to the left. So cosine of pi over 3 would be 1/2. Okay, so in this case, we're going to the left. So it actually would be negative 1/2. That ordered pair would be negative 1/2 minus square root of 3 over 2. Of course, now it's, I don't know why it does this. Okay, so that's why we get this value right here. Sine of 4 pi over 3 is minus square root of 3 over 2, because we know that sine of pi over 3 is square root of 3 over 2. So we're going down, so at 4 pi over 3, we're going down as much as we're going up at pi over 3. And then we have the bonus problem. Cosine of 4 pi over 3 is negative 1/2. The easiest ones, students, are well, like tangent of pi over 4 is 1, because we know that sine of pi over 4 and cosine of pi over 4 are equal. So if you have any questions about any of these other values of tangent, of course, it's important to know where the tangent and the cotangent are undefined. So we know that tangent of all the multiples of the odd multiples of pi over 2, tangent is undefined, like minus pi over 2, pi over 2, minus 3 pi over 2, because those are the asymptotes. You remember that graph up here? All the odd multiples of pi over 2 are asymptotes for the tangent function. That's where the cosine is 0, right? The cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2. And then the cotangent is undefined at all multiples of pi. So that's where the sine is 0. So sine is 0 at all multiples of pi. Yeah, the sine is 0 at all multiples of pi. So you go back up here, right? Basically, better you can see it here. The sine is 0. So yeah, so the sine is 0 at all multiples of pi. So that's where the cotangent is undefined. It's kind of very fast, students. There's your super fast review of trigonometry. Okay, so then there's just some examples I encourage you to go over. So remember now the sine function, the sine of 2x, like number 21 there. Well, the period is actually pi, right? So that's why it says per pi. That PR means period, and it's pi because what you do is it's because of this right here. The period of sine is 2 pi, and you divide by whatever that by the coefficient of x. So in this case, it's 2 pi over 2 pi divided by 2, which is pi. And the amplitude is 3 because it's always the absolute value of the coefficient of the sine function. So basically, we're taking the sine function, and first of all, we're flipping it over because we're multiplying it by a negative, and then we're cutting the period in half. But the amplitude is still 3, and I'm sure you did something like that in your last trig class. Now, what about cosine of x over 2? What's the period? It's 4 pi, right? So, but basically what we're doing is we're taking 2 pi and dividing by the coefficient of x, which is 1/2, and we get 4 pi. And so that means you're stretching out the graph of cosine. So instead of the period being repeating every 2 units or every 2 pi units, it repeats every 4 pi units, and the height now is 2 instead of 1 because we're multiplying it by 2. And so this is kind of this part 3. So we'll do more trig equations later on. There might be the next quiz. There might be some trig equation problems here. I might do if I'm going to put that on the quiz, I might put a few more. First of all, they're in Unit 3, so I might just point out for Math XL which Math XL problems to review for the next quiz. In particular, along with this worksheet, along with this kind of really super fast lecture. And I think I actually have that assignment is due next Tuesday. Yeah, I think your next quiz will be section 1.2 and trig. Okay, but so it says solve this equation. You want x to be between 0 and pi over 2. Okay, that looks hard. We want to find x that solves the equation 2 sine squared x plus 3 cosine x minus 3 equals 0. It's like, what? This is really hard. Okay, so, but it's really, but because we know the famous trig identity, cosine squared plus sine squared x equals 1, we replace sine squared with cosine. So we get the whole formula, get that whole equation in terms of cosine. So sine squared x is equal to 1 minus cosine squared x. So you see how we replace sine squared with 1 minus cosine? And then we just expand and combine like terms. And you end up with the equation right here, minus 2 cosine squared x plus 3 cosine of x minus 1. If you just think of like cosine of x as like a y, just as a variable, like this is a quadratic equation, and let's solve for cosine of x. And you probably did that a lot in your algebra courses. Let's multiply. Don't we do that in algebra? If the leading coefficient is negative, we multiply each side by -1. So we end up with the equation 2 cosine squared x minus 3 cosine of x plus 1. Oh, and these are the kind of equations we hated factoring in algebra. But if you actually factor that, I guess we could use the magic circle. And again, if you're having a hard time factoring, just substitute cosine of x, just substitute y for cosine of x and factor. Right, and just factor that, and just make sure you put the cosine back. Right, you can always factor this. That's a 3y. So you can always factor that that polynomial right there on the left. And then when you're done with that, you just wherever cy, you put cosine of x back. So yeah, you get those two factors. So it factors out as like 2. Okay, so we get those factors. You can actually just verify that you actually get 2y squared minus 3y plus 1. So anyway, so you get the factors 2 cosine of x minus 1 or cosine of x minus 1. So we have to solve for, in the unit circle from 0 to power 2, we have to find an x such that cosine of x is 1/2 and cosine of x is equal to 1. And so cosine of x is 1/2. Well, we know cosine of pi over 3 is 1/2. And also cosine of 5 pi over 3. Because if you're looking at the whole unit circle, and where's cosine of x equal to 1? We know that cosine of 0 is 1, right? Because 1 is the first coordinate at 0 angles, and 1 is the first coordinate when we go around 2 pi radians. And I'm going to stop sharing. I think that's it. So it's just, that's really a very, very quick review of trigonometry. Just some of the famous things the well-known operator. I keep saying famous, but the most well-known operations that we use in a trig class. So I'm going to stop sharing here and